Dear students, I welcome you all to the second edition of video on tangents and intersecting circles. Alright, so before I begin, if you understand the sums which will be solved in this particular video, then please give a like, okay, so that I'll be able to know that you have really understood the sum. Okay, so let us begin. So the first question for the day, that is question number 7, says, if the sides of a quadrilateral ABCD touch a circle, prove that AB plus CD is equals to BC plus ED. Okay, so what is there is, there's a circle and the circle is surrounded by a quadrilateral ABCD and each side of the quadrilateral touches the circle. Okay, so this is a circle and there is a quadrilateral ABCD. Okay, so each side, that is AB, also touches the circle at point P, BC touches the circle at point Q, CD touches the circle at point R, and AD or DA touches the circle at point S. Okay, so that's what is written out here. Okay, now if you see each point of the quadrilateral, that is A, B, C and D, from A you are drawing two tangents, that is AD and AB, right? So both touches, see, AD touches at S and AB touches at point P. So can I say AS and AP both will be equal to each other? Yes, they will be equal to each other using the theorem that we have learned in the first video. Okay, so AP and AS are equal. So AP and AS are equal. Similarly, you can say that BP and BQ are also equal. CQ and CR are also equal, and DR and DS, they are also equal to each other. So that's why we get these many things, right? So let me add all of these. So we have, when we add in the left hand side, we have AP, BP, CR and DR, right? So in the right hand side we have got this. Okay, now after adding and do some rearrangement as well. Okay, so you can see that there is some rearrangement done here, right? Okay, so here AP plus BP. Okay, so when you add them, what do you see? Let us see. So AP and BP, so when you add them you'll get AB, right? Okay, so instead of this I am writing AB. Okay, and similarly CR and DR, so when you add CR and DR, what do you get? You get CD. So this becomes your CD. Similarly AS and DS, when you add them you'll get AD, and similarly when you add BQ and CQ you'll get BC. All right, now if you see here carefully, as I said, AP and BP, when you add them, what will you get? AB, right? So P is there with AP and BP, right? So P will be vanished and you will get only A and B. Similarly, CR and DR, when you add them, since R is present at both, the R will vanish, so you'll get CD. Similarly here S and S are there, so they will be removed and you'll get AD. Similarly BQ and CQ, when you add them, Q is common to both and Q will be vanished in order to get BC, right? So that's what we need to prove out here. So you may pause the video to note down. Okay, so in the second case, we need to show that if the sides of a parallelogram touch a circle, prove that the parallelogram is a rhombus. Now first let us understand what is the meaning of parallelogram. Now in a parallelogram, we know that the opposite sides are parallel and equal to each other. Okay, and if there's a parallelogram whose all sides are equal to each other, okay, in a normal parallelogram, as I said, only opposite sides are parallel and equal, right? So if all the sides will be equal, then the same parallelogram is known as rhombus. Okay, now again, parallelogram is also a quadrilateral. So there's a quadrilateral which touches a circle, so which is similar to earlier question, right? So there's a parallelogram that is a quadrilateral which touches a circle. Okay, so similarly, as I said, or as we did in the earlier problem, I'm not going to show till here. Okay, so you will understand by yourself. It is the same case. Okay, so let me give. Okay, so here it is already given that, as I said, this is a parallelogram, right? So opposite sides, so AB and CD, they will be equal, right? Because they are opposite. And similarly we have BC and AD, so they will also be equal. Let me call this to be equation 5. Okay, now we have, okay, so this turns into, let's see what it becomes. So instead of AB, can I write CD? Yes. Or instead of CD, can I write AB? Yes. So instead of CD, I've written AB. Okay, and instead of AD, okay, AD is equals to BC, no? So instead of AD, I'm writing BC here. Okay, so this becomes AB plus AB equals to BC plus BC. So what is AB plus AB? This is 2AB. What is BC plus BC? This is 2BC, right? So you can remove 2 and 2 from here. So you get AB is equals to BC. Now see here carefully. AB is equals to BC and AB is again equals to CD. So what is the meaning of this? AB, BC and CD are equal, right? Now again BC is equals to AD, right? So I can say that AB is equals to BC, BC is equals to AD, and AB is again equals to CD. So that means all of them are equal to each other, right? That is AB is equals to BC equals to CD equals to DA. Now what are these? All these are different all the sides of the parallelogram, right? So we clearly see that AB, BC, all the sides of the parallelogram are equal. And what is the meaning of this? This means that ABCD is a rhombus. So you may pause the video to note down. Okay, let's move on to the next question. So in the next question, from the figure, we need to prove this too. All right, so let us first prove the first part. So again, we see that each side of the triangle is touching the circle. That means each side of the triangle is acting like a tangent, right? So in the same way, A is drawing, or A is making two tangents, that is AP and AR. So that's why they will be equal to each other. Alright, and similarly BP will be equals to BQ and CQ will be equals to CR. Alright, so the same thing is written out here. So let me give the number 1, 2 and 3 here. Okay, now in order to get this, it is very simple because it is given to be plus. So again we will add all these equations. So in the left hand side we have AP, BQ and CR. So we have AP, BQ and CR in the left hand side, and in the right hand side we have BP, CQ and AR. So BP, CQ and AR, right? So by direct addition we will arrive at our first part of the question. All right, so just by adding 1, 2 and 3 we will get the first part. Okay, so let me call this to be equation 4. Okay, now next is we need to prove that AP plus BQ plus CR is equals to half into perimeter of triangle ABC. Now what is the meaning of perimeter? So suppose if ABC is my triangle, perimeter means total length of the boundary. And what are the boundary? AB, BC and CA. So that means perimeter of the triangle means AB plus BC plus CA. Alright, okay, so in order to do that, let me add the same quantity on both the sides. Okay, so I'm adding AP plus BQ plus CR on both sides. Okay, now we already have this quantity in the left hand side, and again same quantity is being added, so that means it becomes double, right? So that's why I have double of AP plus BQ plus CR in the left hand side. Okay, and in the right hand side, what we are going to do is we will make the pair of the sides, where one of the point is same. For example, here we have got AP and BP, right? So in AP we have got P, and in BP also we have got P. So we will write AP and BP together. So we have AP plus, it is not PQ, this is PB, or you can write BP also. All right, so please make the correction, this is not PQ. So we have AP plus BP. Okay, similarly we have BQ plus CQ. All right, so CQ plus BQ, QB and BQ both are same. And similarly we have CR and AR, both contains R. So we have CR and AR written together. Okay, so we have AP plus BQ. I'm sorry, BP. AP plus BP is what? So AP plus BP is AB, right? Similarly, we have CQ plus BQ. So CQ is this and BQ is this. So when you add them, you'll get BC. Okay, and similarly you have AR and CR. So AR plus CR gives you AC. So that's why we have this is AB, as I said, right? So this is my BC and this is my CA. So we get AB plus BC plus CA, right? So take this 2 to the denominator, you will get AB AP plus BQ plus CR is equals to half of the very same quantity. And what is this? This AB plus BC plus CA is nothing but the perimeter, as I said in the beginning. Okay, so that's why we have showed that AP plus BQ plus CR is equals to half of perimeter of triangle ABC. Alright, so you may pause the video to note down. Let us move on to the next question. Again, the diagram is same here, so everything is going to be same. All right, till here I'm going to write it as it is. Now AP plus BP is what? Since P is there on both the sides, so we have A and B left, so AP plus BP will be AB. All right, and similarly we have AR and CR, so we'll group them. Okay, so AP plus BP is, as I said, AB, right? So AB plus CQ, and AR plus CR, R will be vanished, so you'll get AC. Okay, plus BQ. Let me call this to be equation 1. Okay, now what is given? AB and AC are given to be equal, right? So instead of this AB, can I write AC? Yes. So from 1 I can have, instead of AB I have written AC. Okay, so here we have what? AC and AC will cancel each other. So what is left? So CQ is equals to BQ. That's what is left. Or in other words, can I write this as BQ equals to CQ? Yes, because that's what we need to show out here. Alright, so you may pause the video to note down. Okay, let's move on to the next question. So question says, the radii of two circles are 6.3 and 3.6 centimeter. State the distance between their centers if they touch externally, if they touch each other internally. So there are two cases. Let me take one case at a time. So whatever is given, let me note down first. So radius of bigger circle is given to be 6.3 and the radius of smaller circle is given to be 3.6. So the first case says the circles touch each other externally. So this is the case they are talking about. So there are two circles which are touching each other at point P externally. Okay, so we need to find the distance between the centers. So the centers are O dash and O. Okay, so the distance between them is O dash O, or you can say O dash, right? Okay, so when the two circles touch each other at point P externally, so this is the first case, as I said. Now O and O dash are the centers of the circles. Okay, so let us join OP and O dash P. So everything is shown out here. Okay, so we have OP. So OP is the bigger radius. So bigger radius is given to be 6.3, and next is O dash P, right? So O dash P is the smaller radius, which is 3.6. Okay, now as I said, our aim is to find the distance between the centers, that is O dash, right? That means if I add OP and O dash P, okay, so P is present, right, at in the both, so P will get vanished. So what is left? O and O dash. So we have O dash. Okay, so O dash will be OP plus O dash P. Now what is OP? OP is 6.3 and O dash P is 3.6. Okay, so if I put the value and add, I'll get 9.9 as my first answer. Okay, so this is our first answer. Now let us go to the second case when they touch each other internally. Okay, so this is the case out here. So there's a bigger circle and there's a smaller circle and they touch each other internally, okay, at point P. Okay, so again here we need to find the distance between the centers, that is O dash. But in this case, if you see here carefully, O dash will be calculated by subtracting O dash P. Okay, so this part from OP. Okay, so OP is longer length and O dash P is shorter length. Okay, so if you remove O dash P from OP, so only this part is left, right? That is O dash. Okay, so we have O dash equals to OP minus O dash P. Okay, so let us put the values. So OP is 6.3 and O dash P is 3.6. So when you subtract, you'll get 2.7. So you may pause the video to note down. Okay, let us move on to the last question for the day. So question number 12 says, from a point P outside the circle, so there's a point P outside the circle with center O. Okay, so two tangents are drawn, PA and PB. So PA and PB are drawn. Obviously they will be equal in length as well. So we need to prove that angle AOP is equals to BOP. So AOP means this angle, okay, and BOP means this angle. So this angle and this angle, they will be equal. That's what we need to show out here. So let us first see the first part, and we'll go to the second part. So the first part is in triangle AOP. So in this triangle and BOP. All right, so there are two triangles being formed here. So as I said, AP and BP will be equal because they are tangents from the same point P, which is lying external to the circle. Okay, so as I said, AP and BP will be equal to each other. Okay, and in this triangle and this triangle, there's one side which is common to both the triangle, and that side is OP, isn't it? So we have OP equals to OP, they are common to each other. And which one is left now? This side is left and this side is left, that is AO and OB, right? So OA and OB both will be equal again because they are radii of the same circle. Both are radius, right? OA is also radius, OB is also radius. So that's why we can say that if all the sides are equal in both the triangles, so we can use this all the side, this all the side, this all the side. So using SAS, I'm sorry, this is SSS, not SAS. Okay, so using SSS, we can conclude that these two triangles are congruent. Please note that this is SSS. Okay, so these two triangles are congruent. Now if these two triangles are congruent, then by CPCT we can say that this angle and this angle are equal to each other. All right, so you have already learned this kind of problems in your similarity chapter. All right, so we have shown that angle AOP is equals to angle BOP. So this is our first part. Now let us look at the second part. So second part says OP is the perpendicular, this means perpendicular, so perpendicular bisector of chord AB. So if you see here, AB is what? AB is a chord, right? So there's a circle and AB is a chord. Now OP means this line. So this line not only bisect this, bisect means AM will be equals to MB. Okay, so that's what we need to prove here. Okay, so not only it will bisect, but it will bisect in perpendicular manner. That means this angle or this angle will be 90° each. All right, so that's what we need to show out here. Okay, so let us begin. So let us have a look at OAM. So OAM means this triangle. All right, and OBM. So OBM means this triangle. So let us show that these two triangles are congruent. All right, so again OA is equals to OB, right? So they are equal because they are radii of the circle. Okay, so we have angle AOM. Okay, so let us see what is AOM. AOM, M means this one, AOM means this angle, right? And this angle is equals to BOM, that is this angle. Why? Because we have already showed here, right? That's what we proved just now, right? This angle and this angle, they are equal. That's what we showed, right? So we proved that angle AOP is equals to BOP. Okay, and OM. So OM is common to this triangle and this triangle, both the triangles. So what happened here? We showed that side angle side, right? So using SAS criterion of congruence, so we can say that these two triangles, that is OAM and OBM, are congruent to each other. All right. Okay, so if they are congruent, then again by CPCT we can say that AM and MB are equal. Okay, so AM is equal to MB. So from here we see that OP has bisected AB, right? Bisected means AM and MB are equal. Now we have just showed the bisector part, we have not shown the perpendicular part. All right, so let us see this as well. Okay, so perpendicular means we need to show this angle, that is AMO or BMO will be 90 degree each. All right, so again by CPCT I can say that OMA, that is this angle, and OMB, that is this angle, so they will be equal by again CPCT, because these two triangles are congruent. Okay, now if this is the case, then what is the value of AMB? Angle AMB is a straight line, isn't it? So that's why it will be again 180 degree. So if this is 180 degree, then the sum of this, that is OMA, this angle plus this angle gives me AMB, which is 80 degree, right? So from here it is clearly seen that since both of them are equal, right, so obviously the value of both has to be 90 degrees, because 90 plus 90 only gives me 180 degree. All right, so we have OMA is equals to OMB equals to 90 degree, that is this angle is 90, this angle is also 90. So we have already or successfully shown that this is not only bisector, OP is not only bisector, but it is bisecting AB in a perpendicular manner, right? Because it is 90 degree. So that's why we say OM or OP is the perpendicular bisector of chord AB. All right. So you may pause the video to note down. Thank you very much.